Okay, here is the video that kind of explains the experiment 5, the clove steam distillation lab report, the expectations, and how to use the rubrics that are on the website as kind of a checklist. So first let me show you where the files that are important are. Underneath in your home screen you see a lab report instructions, and there's a format for writing the lab report, which is the lab report instructions, and then also the lab report grading rubric. So those two are important to look at. The format for writing the lab report shows the initial requirements. And the other thing that we're going to look at is under experiment 5, there is in the experiment handout, at the end of it, it shows you what to include in the experiment 5 lab report. So I've opened up all three of those documents. So let's look at the experiment 5 handout first. So if you go to the end of the experiment 5 handout, it says a full written lab report will be due for this experiment. So your report should follow the instructions and grading rubric for organic lab reports, which are the two files that I just showed you a moment ago. So first thing you want to include is your experiment number, which is number 5, the complete experiment title, your name, date, and the lab section and day and time. And you're going to include that at the top of the first page. You do not need a cover page. We will try not to kill too many trees because 120 students at X number of reports at X number of cover pages probably kills one tree. But you want to include this at the top of the first page. Then, as far as the objective of the experiment goes, you're going to have that as the next section. Now, when you write the objective of the experiment, the first thing you want to do is state what is the experiment, what's the purpose of the experiment, what's the objective. Then you're going to include the method of sample isolation. So how did we isolate the sample? Did we do any purity? Did we do any sample purification, such as recrystallization, chromatography, distillation? And then did we analyze the product for purity, and if so, how? Melting point, boiling point, refractive index, TLC, GC. And it's usually no longer than a paragraph. So that's the first real part, is the objective. Now let me go to, in terms of format, the format for writing the lab report. It says that a cover page doesn't have to be included, but it basically says the same thing as far as the objective of the experiment. Now let's go to the lab report grading rubric, because this is kind of what we're going to use. So here are the parts of an objective. First of all, you should have a statement about what the objective of the experiment is. And you'll be graded on whether it's complete, whether it's only partially complete, or whether it's totally wrong or not there. So think about, for the cloves experiment, what was the objective of the experiment? Seems to me as if we did what? We we isolated the essential oils, or something along those lines. We isolated the essential oils from cloves. That was our goal. How did we do that? Well, we did that by steam distillation, extraction, and so those would be a second statement. The first is the experimental objective, and then how we did it would be the second statement in that. So down here you'll see the objective. It lists the chemical names, reactions, and or techniques. So we want to include that. So instead of just saying we're going to isolate the essential oils from cloves, let's give them chemical names. So the objective was to isolate eugenol and eugenol acetate from cloves. In other experiments we'll have reactions, and we may even have techniques. So then the techniques part would be the second one. How did we isolate eugenol and eugenol acetate from the cloves? by steam distillation, followed by extraction. The next part, and you can see the grading rubric basically says, that you had almost all of the chemical names. That means it's greater than 90% correct. Then if you're in the 70 to 90, you're in this range. If you're only half correct, you can only get half credit. If you're less than half, you'll get less. And if you are really not good, then you'll get 0. So when you're writing these, kind of take a look and see where you fall within these categories, at least as far as you think. And you can use it as a checklist. Did I include the objective information? Then methods of product isolation or separation. So how did we isolate the product? Extraction. Did we do any purification? Well, in this case, no. We really didn't purify. We didn't do any distillation of the oil. We didn't do any chromatography. So we just isolated the compound by doing an extraction. Then what methods did we use to determine the purity? Here's something that's important. Whenever I ask for the methods of determining purity, one of the qualitative methods to determine purity is the observation, its appearance. So that's always going to be something that you put down. Now, is it quantitative? No. Is it qualitative? Yes. This was supposed to be a yellow oil. So if you had like a dark brown oil, or if it was black in some cases, I saw a couple of those, that's an indication that the sample isn't completely pure. How impure is it? That's what we have other methods to do, but always include observation, always include the appearance of the product as a method of product purity. Then what other method did we use for this experiment? GC. So when you put all of these together, all of these parts, that becomes your objective. What did we do, including the names of the compounds or the names of the reaction? How did we isolate the product, or how did we separate it? How did we purify it? And how did we determine the purity of the product? Those are the 4 essential things. Okay, so now let's go back to the handout and see what's next. A tabular summary of names, structures, and relevant physical property data for eugenol, eugenol acetate, and dichloromethane. So this should be the same one that's in your notebook. Make sure you include the literature references for this. And the literature references, actually, this is the handout, how to properly format literature references, just for future use, I believe is in the lab, the format for writing the lab report. So actually I could go to the format for writing the lab report and see what it says, but it just says a balanced reaction equation. We don't use that in this case. A tabular summary of data, well, that's what we're using. Actually, I just cut and paste this and put it into the handout to tell you what to include. So let's go to the rubric and see what does a tabular summary of data include. Did we write reaction equations? Nope. So, creating a table of physical properties. The names, structures, and physical properties of solvents. So, is the table complete? Did you include all of the names, structures, and then the appropriate physical properties? What are appropriate physical properties? Things that you actually need to know for the experiment. Obviously, if you're going to take a melting point, the literature melting point would be a physical property. But let's say I was to do rotary evaporation. I need to know what the boiling point of the solvent is and the boiling points of the compounds I'm isolating, so that I know that the rotary evaporator, number 1, is hot enough to remove the solvent, but number 2, not hot enough to actually boil the product that I'm trying to collect. Notice it says names, structures. Make sure you include your name. Make sure you include the structures, and you can cut and paste the structures from Sigma Aldrich or from the internet. That's perfectly fine, but you need names and structures and then the physical properties. And obviously down here you need to include a literature reference. So the literature reference is correct and in the correct format. It's correct but not in the correct format. Let's go to the format and just see if I stuck this. No, I didn't, because it's in its own separate page. So, since this is on the fly, let's go find the correct formatting for references. Here, no. Instructions for references. Format for references. So, we'll see a little panda on the unicycle, and here is what we call the American Chemical Society, which is for chemistry, is the leading leading journal referencing system. You can find some of that in the ACS style guide if you are really overly ambitious. Or Dr. Weiner has a website that has also some of the referencing practices that are done. In chemistry, everybody references by superscript, and these are the examples taken in some cases from Dr. Weiner's website about how to properly reference. So here is how you would properly reference a website. Make sure you reference my handout of the experiment. If you have journal articles, here are some examples of how to reference those, and books. So that finding those references, it's its own file on the Canvas website. So going back to our grading rubric, try and get them in the correct format for the references. This is just to prepare you for what you would use if you went on to physical chemistry lab or physical chemistry. I know most of you aren't going to do that, and those of you that do are probably going to hate it, but that's next year. Don't worry about that now. So you want to get into the habit of using the proper references, and so that sheet's there for your use this semester and for later on. Okay, so that's how you create the table, and hopefully you did all of this in your notebook, so then you've already done it once. All right, let's go on to show the calculation of the theoretical yield. Well, the theoretical yield in this case and I totally made it up. I have no idea what the theoretical yield should be, how much you should expect, how much eugenol and eugenol acetate you should expect from 2.5 grams. I know that's shocking, but I've been using this estimate for the last 15 years. So it said that you would be able to obtain 50% of 20%. So overall, that's 10% of 2.5 grams is 0.25. What if you went over 100%? You could legitimately have gone over 100% because the calculation, I don't know if it's correct or not. It's just sort of an estimate. Now, you could say, why don't we just determine the percentage based on the 2.5 grams? Then the percentage is going to be really, really, really small. So the handout lists how to calculate the percent yield, but if we have a chemical reaction, show how you get the limiting reagent, show how you get its calculation. So identify the limiting reagent, then you get graded on how the calculation is done, the theoretical yield calculation, and so you can see, okay, is your calculation correct and the theoretical yield is given in grams? If that's correct, you'll get 4 out of 4 points. If the calculation's correct but you don't give me the theoretical yield in grams, then you'll only get 2 points, etc. So as you go through here, again, use this as a checklist. But then you can kind of estimate, well, where am I at on this scale? Here's our more important, the percent yield calculation. The calculation you give me, is it completely correct? And completely means it's shown completely, and correct means it's correct. The calculation is partially correct. Well, if you only give me part of the calculation, or it's only partially correct, then you'll be at this level of grading. So show the complete calculation. You can handwrite it on the paper copy, or you can write it. You can type it out. Either one is acceptable. For this experiment, probably not a big deal to type it out. All right, next, experimental procedure and observations. Provide a reference for the experimental procedure and list any modifications that were made to that procedure, and you will always include all observations and data recorded during the experiment. Now, sometimes people will say, do I write out the complete procedure? Do I just provide a reference? What should I do? And my first answer to that is follow the directions. So here's the directions. It says to provide a reference. How am I going to provide a reference? Well, I would go back to my format for references, and here's a reference for a website. Here's the reference for the handout. So follow that. Then list the modifications that made. Some modifications I made. I told you to do things a little differently. You may have made modifications on your own, which may or may not be important, may or may not cost you product. But if you have those listed in your notebook, certainly write those down. One modification I could think of in this experiment of the cloves is that perhaps you didn't completely collect 60 milliliters. That's important to note because that will tell you if you got a little bit lower percentage, maybe it's because you didn't collect the full 60 milliliters. So as we go back to the rubric, let's see, we're not drawing reaction mechanisms yet. We're not identifying side products and side reactions yet. How about writing the experimental procedure? So in this case, a reference to the procedure. Is it given and correct? That you get 4 points. If it's given but not correct format, you would get 2. Now, I'm not asking for the completed procedure, so this doesn't count. But changes to the experimental procedure, did you include all the changes to the experimental procedure? Did you include only 70 to 90%? So what happens is the TAs get a list of that when they're grading, and then depending upon how many of those you included, this is where you show up. And so if you got them all, you'll be here. If you only got half, you'll be there. I don't include in the rubric the actual answer key because that would make future reports pretty good because everybody would have the answer key. But did you include all the changes? That's what you want to use this again as a checklist. Did you give me all of the experimental data that you had? Did you include all of the experimental observations? Okay. Now you may say, where do I put the observations about product loss? That's in the section that's coming up. Okay. Isolation and purification scheme. Yes, you have to do an isolation and purification scheme for this experiment. I don't know anything about an isolation or purification scheme. Well, where would I find that? I would go back to this website, and in experiment 5 it says somewhere how to draw a separation scheme. So we would click that, and now we have a handout on drawing a flowchart separation scheme. Boy, it'd be nice if those big black dots weren't there. Let's see if there are any more big black dots. No. So that handout's okay. This is supposed to be this is supposed to be A, and then B, and C, and D, and I don't know what else. I'll try and fix this and put. I have to use another PDF maker. That's neither here nor there. We'll fix that. Okay, but this is where you find out how to draw the separation scheme. So draw the separation scheme starting from when you put the cloves in the water in the round bottom. Make sure you include all the structures of the organic compounds. You're probably going to handwrite this unless you are superly overly ambitious to cut and paste everything together. Alright, so isolation purification scheme, let's see, is that in my rubric? It sure is. Are all the steps shown? Are all the structures of the compounds shown? So, again, this is how you'll be graded on that. Of course, all the steps means it's correct. Next, tabular summary of results. Now, tabular summary of results is something I use. Does it have to be in a table? Not necessarily. It could just be a listing of results. that's up to you. What we're looking for is that all the data is there. So provide a tabular summary of all the data except your raw data. So don't put the weights of vials and pieces of weighing paper and other stuff. Give me the final masses of stuff that you used. So data obtained for the products, including the yields, the percent yields, color and appearance of the product. Again, that is a very important judge of purity. It's not quantitative, but it is qualitative. And then GC results, which we'll have this time, melting points, boiling points, etc. And whenever you give me a piece of data as a result that has a literature value going with it, you should report that. So if you report that your melting point was 50 to 51 degrees, I would like to immediately see what the literature value is so I can see how close you are. So make sure you include the literature values for things that have literature values. All right, going to the tabular summary of results rubric. Okay, so here are the things that should be included: yield, the theoretical yield, and percent yield. So I want to see how many grams you made, what you should have made, and what your percentage is. Then for purity information, if you're doing a solid, it should include a melting point, the literature melting point then, as I just said, and the physical appearance. For liquids, if you measured the boiling point, then include the literature boiling point. Did you measure the refractive index? Well, there should be a literature refractive index to go with that. What was its physical appearance? And then if you did chromatography data, like in TLC, then you would include the compound and RF values. We'll talk about that in another experiment. But in this case, for the GC, what was the compound for each peak? You should indicate the compound, what its retention time was in minutes, and what percentage that peak was. So the GC is usually, it's easier to do it as a table. The data table is properly labeled. So if you do make a table, are all the columns labeled and properly, and you have units in them? And then most of them are not properly labeled. And then finally, no data was included. Is the data table organized? It's completely organized. It's mostly organized, and a few of the data are hard to find. It's about half organized, and I can't find half the data. Most of the data table is not organized, and I can't find it. And then the data table is completely disorganized. It's impossible to find data, but it is easy to find out how many points you got, because that would be 0. All right, so again, these are just kind of checklists. These two are actually somewhat aesthetic, but quite honestly, we don't want to search for your data. And part of writing good lab reports is people can follow what you did, and they can immediately see where the data are for the results. So these are checklists. Again, you want to make sure, where do you think you fall on that scale? Of course, everybody thinks they fall under 4. Maybe they do, maybe they don't. Okay, so far what have we done? We've outlined the experiment in the objective. Notice that I do not ask for a background, because the backgrounds would be, I think the backgrounds in first semester organic are a little bit difficult to put together. Then I asked you for your data, your tabular summary, calculate the theoretical yield, give me the experimental reference for the procedure, and then show me any modifications and also the observations and data, in this case the separation scheme, your summary of results. Now let's discuss the results. So in the discussions always have 3 parts: purity, yield, and then overall effectiveness of the experiment. One thing to stress is that whenever you discuss yield or purity, tell me the data that you're actually using to draw your conclusions. So, when you're discussing the purity, list and compare any of your physical data that you used to make the conclusions. So don't just say, my melting point was good. Okay, where's your evidence? My melting point was 50 to 51 degrees, and the literature melting point was 51 to 52 degrees. Therefore, this indicates that the product had good, excellent, outstanding purity. But show the data that you're using to draw your conclusions. This will get tedious, but you really need to do that. Assume that I am only going to read the discussion part of your report. That's what I want to see. I want to be able to see, is that conclusion that you're drawing, or is that analysis, is your analysis correct? If you tell me that you measured 50 to 51 degrees, but the literature value was 100 to 102, I'm going to be like, okay, and what conclusion did you draw? My product was super pure because it melted at 50 to 51 and the literature value is 100 to 102. I'm going to say, yeah, not so pure. So include the data. That also includes the yield. So tell me, how many grams did you make? What percentage was that? So don't just say, I got a 52% yield. Well, how much did you make in grams? So show me the grams and the yield in the yield discussion. So this part, the first one is purity, include the data, and then draw your, and then do your comparison. I guess we're not going to make the actual final conclusion until we get to the conclusions. But at least show me. Also remember that in here you should probably include the appearance. So the appearance of my liquid was, it was a light yellow oil. Authentic clove oil has a light yellow appearance as well. Then as far as the percent yield goes, if your percent yield was less than 100%, then you should list places where the product was lost. I had a yield of 50%. I had product loss in these steps. If your yield is over 100%, then you need to tell me why the yield is over 100%, or you can draw some or you can give me some hypothetical situations. It would be better if there was actually data to go with those. So for instance, in this experiment, I noticed lots of products had little droplets of water in them. Lots of products. Or maybe some products had dichloromethane in them. So if I got 110% yield, that means my mass was higher than it should have been. You did not violate any laws, laws of conservation of matter. But that means you got extra stuff in your product. So, do you have any suggestions? Oh, I think that the product was wet. Great. Do you have any data that might show that? Well, there is a certain pattern of GC that tells me the product is wet, and I don't think I wrote that, but if you're concerned, I can show you, I can tell you what your GC would have looked like. But let's not even go that far. Let's say dichloromethane. In the GC, you'll actually see a peak corresponding to dichloromethane. So if you say, well, my product contains some dichloromethane, in the GC you can see this peak, therefore that might be one of the reasons why it's over 100%. Great. Then for the third part is to provide a discussion of the overall effectiveness of the experiment. In the grading rubric, I have given you some things to think about. Don't feel limited by those. You can be creative and come up with your own. So now let's look at the discussion grading rubric sort of again as a checklist. First thing, you include physical property numerical values for each product. So physical appearance, give me the melting point. Also then give me the literature melting point. If you get boiling point, tell me what the literature boiling point is. Refractive index compared to the literature refractive index. The TLC results, you can describe those. You don't have to include the RF values or anything like that, because in the table above that, you would have had in your TLC, you would have the compound identified as well as its RF value. So just you can sort of discuss what you see. Then that's just the data part. Then discussion of the product purity. Is your discussion complete? Does it include all the key elements? What are the key elements I'm talking about? First of all, when it came to purity, did you discuss all the things that you needed to tell me about the purity of your product? Appearance. Discussing the GC results in this case. Those are the key elements. And then if you're missing some key elements, then that's not important. Now, is the discussion of the product purity supported by experimental data? So in other words, did you include experimental data to support your discussion of the product purity? So in other words, you said my product was, light yellow oil, and the literature value is it is a light yellow oil. Or my melting point was 50 degrees to 51 degrees. My literature melting point is 100 to 102. So when I say discussion of product, what I mean is you're laying out the product purity, but then you include the experimental data as a comparison. Then as far as the purity comparison of the experimental data to the literature values. So you should kind of make a comparison there to show that. All right. And this may actually go down in the conclusions. I'll have to see how people did. So yield in the grams and the percent yield data. So in other words, did you include the yield? Did you include the percent yield? In your discussion of yield, did you give me all of the sources of error? So it says a discussion of product yield is given, but only 4 sources. Actually, I've always asked for 5 sources of error, but only 4 sources of error would be enough to get full credit. If you only give me 3, then you're going to get a little lower, 2, 1, and 0. So make sure if you're less than 100%, you include 5 sources of error. Then if the discussion of the yield is greater than 100%, then you need to include a reason. And by valid reason, we're kind of giving you the benefit of the doubt here. If you make up some absolutely, there's no way that is a reason, then you'll be moved to this category. But if it's a valid reason and you have to support that by experimental evidence, if there's experimental evidence to support it. If the evidence isn't there, you don't have the evidence to support it, because you just don't have that kind of evidence, that's perfectly fine. But if you say that I got over 100% and you say and dichloromethane was in my product, but then you don't tell me about the GC evidence, and the GC evidence is there, then you'll be moved to here. So a discussion of the product yield includes a valid reason, but no experimental evidence is cited, and then you just didn't give me a valid reason, period. Now, as far as the evaluation of the effectiveness of the experiment, well, I've given you some. Like I said, this isn't to stifle your creativity. How easy was the procedure? Did you have any difficulties with the procedure? Was the clarity of the procedure instructions okay? Did you have difficulty understanding the procedure instructions? Specifically, tell me where, and that can help me in the future improve the experiment procedures. You can give me suggestions for improvement for the procedure. You can give me suggestions for improving the instructions. Others that seem reasonable. My classic story here is that many years ago, a student was probably feeling very frustrated with Organic Lab, and they went off in the evaluation of the effectiveness of the experiment. What did they say? And they were getting tired of having to write down all these observations, and they really critiqued the experiment, and they were having a bad day, very bad day. When the TA showed it to me, the first question I asked was, well, I mean, did they include this type of discussion? And they said yes, and I gave them full credit. And I said, well, that's all that matters. So, you know, if you're having a bad day, maybe in your first draft you want to write others that may seem reasonable, and then maybe if you're not having such a bad day later on, you might want to go back and think about whether to include those. But these are just some ideas. I want to see, you know, is there a way to improve the experiment, or is it just fine? But again, kind of think about this, and include. It says to include at least 3 of them. If you want to come up with 3 of your own, that's perfectly fine. Now, conclusions. So as far as the conclusions go, we want to start with a clear and concise statement of what you learned in the experiment. So that's what I want to see. What did you learn in this experiment? What did you learn in the cloves experiment? Now, one of the reasons why I'm asking you what you learned is because I'm going to compare that to what I wanted you to learn. And maybe you learned extra stuff. That's great. But if you didn't learn from your perception what I wanted you to learn, then I need to go back and take a look at the experiment and see if I need to improve it to make it a little bit clearer. So just tell me what you learned in the experiment. So did you include a statement as clear, straightforward, and written with correct spelling, grammar, etc.? So I want to know what you learned correct, written in decent English. Then if it's clear, maybe I'm a little confused, maybe you didn't use correct spelling, then you might come down to here. And if I'm totally baffled and I see lots of, you know, grammatical spelling mistakes, then it might go to here. But these are more or less style issues. Just give me, you know, try and make it clear. And what did you learn? That's the first step. Then 3 items that were learned should be given. And these will vary from experiment to experiment. So I guess I would like to see 3 things that you learned in the experiment. That's what I would like to see. I suppose I should have put that over here, but I guess everybody's reading the... It says consult the grading rubric for additional details. Good, so everybody consulted that. So I want 3 things that you learned. So, did you give me 3 things, and were they straightforward, etc.? Then, the conclusions of the experiment. Tell me what the conclusions are. Now tell me about your yield. How was your yield? My yield sucked. Don't use sucked. But my yield was low. That's the conclusion. Period. Okay? Why was my yield low? That's the discussion part. So your conclusion was, my yield was low. My yield was over 100%. Great. Now, my yield was low, and then you use quantitative data very briefly to show that. So, my yield was low at 45%. That's what I mean. That's what I mean by that in terms of using the quantitative data. So I had a low yield is not sufficient. I had a 45% yield, which is low, is good. So include the quantitative data. Now, we have to be careful here in terms of the conclusions. Let's say we go to purity. My product was what I consider to be mostly pure because the melting point of the product, 50 degrees, matched well with the literature value, 101 degrees. Well, that would be a poor conclusion, 50 and maybe 51. right? We're not getting into an elaboration of anything more than that, just a statement of fact with data. My product was pure because the GC showed only the 2 peaks of the product that I was getting. So for each of your conclusions for yield, for purity, you want to include a statement and then include the quantitative data, but don't discuss the quantitative data. Just make that statement. Then the conclusions in the experiments are summarized in a clear and concise way. So again, you want to make the statement clear, best English. Don't try not to have it confusing. And I guess what I was saying is my product was, my yield was low at 4 grams and 52%, would be a statement presented in a clear, straightforward way, hopefully with good English or excellent English. If it get to be a little bit confusing, then they will. Now, the discussion should not be included in the conclusions. So, don't discuss why your yield was low. Just say my yield was low. The discussion should be where you showed product loss. Or the discussion should be where your yield is over 100%. Or the yield is, the discussion is where you have talked about the fact that there was dichloromethane peak in the GC as an impurity. So, in this case, you shouldn't include those parts of the discussion. Now, that's where the report ends. I have included some other things that if I had time, and I might make time for this, that when you write a lab report, here are some other things as far as the presentation of a lab report. You may want to file this away for later classes, but these are the kinds of things that will make a very good lab report. And as you're writing, as you're writing different kinds of lab reports, these may be good checklists of things to see. Have I done this? Is the writing grammatically correct with proper syntax, spelling, and style? So, if it's grammatically not correct, at some point in the future, your lab report's going to get a very low grade because we expect people to write with proper grammar. So here are some of the criteria that we might use if we were going to do that. The writing is clear, succinct, and coherent, whatever that means. Well, if it's confusing and incoherent and just as sort of like this video, just rambling on in all different kinds of areas, not succinct. So you try and make it clear and coherent. So then you can see, do we have some clarity issues? Do we have clarity issues to the point where I'm beginning to wonder what you just wrote? And there's just no discernible purpose or organization in the writing. Yeah, try not to do that. Student demonstrates clear and thoughtful scientific inquiry. A little bit harder to define, but sort of the scientific inquiry would be, I would consider that to be supporting your data, supporting your conclusions in discussion with actual data. Because if you just say, my product was pure and you include nothing, that's not thoughtful scientific inquiry, because you didn't provide any evidence. Students demonstrate that they have successfully learned what the lab is designed to teach. This is as much a test of me as it is of you. So I'm actually not going to use this rubric strand other than to test myself. So if 80% of the students have learned what I thought they should have learned, then I give myself a pat on the back and say, why isn't it 100%? If it's 50%, then I'm like, wait, hold on for a second here. What did they learn? And then I got to go back and look at the experiment, and I have to say, oh, I was stressing this, and that's what you picked up on. So this isn't about you, it's more about me. But tell me what you learned, because that's what I want. Ultimately, that's what the experiment is about, is to have you learn something. What did you learn? And then some of the other things: student communicates knowledge of purpose and design of the study and shows the student fully understands the work and has made the ideas of writing their own. Or protocol writing is clear, concise, and non-repetitive. Past tense is used. This part of the rubric would be for procedures. Procedures should always be in past tense. Some of these you may want to use if you ever do an honors thesis or any kind of lab paper. Feel free to use these rubrics. These kind of criteria. They're actually not mine. I took them from another university. Discussion narrative contains significant evidence of thought, critical thinking, analysis, interpretation, and integration, whatever that means. And then students use a scientific terminology that is both technically correct and enhances the quality of the writing. This is probably a science teacher pet peeve. But you want to make sure that you use the terminology correctly. I can't think of an example right now of incorrect use of terminology, but I will by the end of the semester. And sometimes it's just a question of, if I see that, then again, it's my job to sort of point that out and teach you. Well, this isn't what that term, it's not, this word does not mean what you think it means. To quote what? Princess Bride. So there, you want to make sure that your language actually means something, but at this level of your career, you're just beginning to find that out. So again, some of these rubrics, if you take a look at them, these kinds of things will probably be demanded of you later on. But I just put them in here to kind of give you a sense of some other things, intangibles that might go into future lab reports that you write. So anyway, the experiment stopped at discussion should not be included in the conclusions. Okay, so this rubric gives you kind of a checklist to look at. It includes every conceivable thing I could ask for, and obviously some of these things aren't included, so they won't be used for grading. Now, can I show you in the last minute or two, if you haven't already turned this off, and if you have, it is going to matter anyway because you're not listening to me. When you go to the grade book, shouldn't have done that. We need to delete that before somebody's grade shows up and I've just FERPA violated them. Oh, that was close. In the grades, when you go to the grade book, here, when you click on your score for anything that I've used, that we've used one of these rubrics to grade, you will actually see that rubric come up and you'll see what was clicked on in the experiment or in the report. So that'll give you kind of an idea of where you're missing points. And ideally, the TA should have written on the lab report or in the notebook what you were missing so that you can then go back to it and see what specific information you should have included or where your calculation was wrong, etc. But all of those rubrics that I showed you, I can show you this much. All of those rubrics that are in there are actually part of are used by the TA. So let's take a look back here at let's go to experiment 5. See, this rubric is actually in what they have graded. So did you include all the information? 5, 4, 2 to 3 pieces, 1 piece. You'll actually see this then with one of these boxes clicked. That was your score for that part. So if you don't see this, come and see me, but this is actually how this is how you're being scored, and and so you can see where you're deficient. What I can do is I can run the statistics on this and figure out if there are places where everybody needs to improve. One thing I will say is probably people haven't been including enough references, but I can find statistics on that. So I can say 50% of you did not include statistics. I want 0% of you to include references or something like that. So that's the beauty of Canvas, is these rubrics. So you will see those, but I can't show them to you because I would violate somebody's FERPA rights, and that's not acceptable. Alright, I don't know how long this has been, but it's been too long. So if you have questions about the report, please feel free to come in and see me. I'd give you exactly the dates when the reports are due, but I'd like to use this video again. So if I give you a date for this year, it won't be the same as next year, etc. But I will send an email out in a few minutes to everybody telling you that the video is there for you to watch, and also to come and get your GCs, and your report will be due whenever it's due. So come and see me if you have questions.